Okay, so sorry, I was running out of time in my last video. I had to stop it before I actually lost my video. Okay, so for part C, we're going to use the definition, the alternative form of derivative. So I'm going to go ahead and rewrite this. It's f prime of c is equal to the limit as x approaches c of f of x minus f of c all over x minus c. Okay, so I have a huge problem. As you notice, in my last problems, I was only dealing with one function. Look at letter B, only one function. Look at letters A, it's only one function. This time, I have a piecewise function. So that means I don't have just one function. But remember that in a piecewise function, you have one side. If you have two functions, then that means you have one side of the function and the other side of the function. So we have to split off the limit as a plus and a minus from both and right sides, left and right sides. So let's go ahead and do this. So it's going to be f prime of 1 because my c is 1 is equal to, well, let me do the left side of the limit first. The limit as x approaches 1 from the left, which would mean is the top function because x less than 1 means from the left. So that means I'm going to use a top function plus 2 minus the top function again, but with 1 plugged in. All over x minus 1. So let me go and evaluate this. X squared plus 2 minus, well, this is 1 squared plus 2. This becomes 3. So it's x squared plus 2 minus 3 all over x minus 1. Simplifying this some more would yield a x squared minus 1 over x minus 1. Now we know what x squared minus 1 is. It's a difference of two squares. So let me go ahead and continue over here from the left. The limit as x approaches 1 from the left, from the left, from the left. Okay, good. Is x minus 1, x plus 1 all over x minus 1. These factors cancel. So I really have just the limit as x approaches 1 of x plus 1, which is 2. So that is my left-hand limit. Okay, I'm going to go ahead and highlight this part. Now let me go ahead and do it from the right. So the limit as x approaches 1 from the right is now the bottom function. It's going to be 3x minus 3 times 1, which is the limit as x approaches 1 from the right, 3x minus 3 over x minus 1, which I can factor out a 3 from the top, and I get 3 times x minus 1 over x minus 1, and I see that I can cancel those out, and with the limit from the right is 3. Does the limit exist? No, because as you can see, the limit from the left is 2, the limit from the right is 3, and these do not equal. So we say it's not differentiable. And you're probably wondering, well, Mr. Hernandez, why are we doing all these problems just to find out that they're not differentiable? Well, if they were differentiable, it would be a lot easier problem. In the AP exam, they're not going to give you a problem where they're just going to be so easy. You just plug it in and you check it and that's it. They want you to know your calculus. So by knowing your calculus, that means knowing your formulas for finding the derivative. Okay, well, this concludes 2.1, derivative and differentiability.